Hello everyone, my name is Shambhavi. Hope you all are doing well. So into this respective video, we will be discussing about your hashing in the data structures and algorithms into your Python programming language. Right, that is what we'll be discussing right now about the hashing, like what is it, what things do we have up over here, what are the properties of the same, right, what are the subtypes of the hashing, right, all of these particular things we'll be discussing up into this particular video. So let's get started up here everyone. So I'm gonna put in some quotations like this, right, and inside that I'll start with my stuffs. Okay, so hashing, first of all, let's discuss that what is it actually. Okay, so this refers this okay, hashing refers to, it refers to the process, it refers to the process of generating a fixed size output from an input, okay, from output from an input, one second, from an input of variable size using the mathematical formulas known as hash functions, right. So what is hashing? It refers up to the process of generating out a fixed size output from an input of variable size using the mathematical formulas which are known as your hash functions. Okay, that is the one thing which we have up over here, that is about your hashing, right. Now, like whenever you are having and you want to generate out a fixed size output from any sort of the input of the variable size, right, at that time you generally prefer using up this hashing, right. Now the technique determines an index or location for the storage of an item in a data structure, right. So this technique, it determines an index or location for the storage of an item in a data structure. That is what we have up over here in the hashing. That is the main thing over and the main idea behind this respective thing. So whenever you want to generate fixed size output from any input of any variable size, right, in that particular case we use up the hashing, and this particular technique, it determines up the index or the location for the storage of an item in a data structure. That is what we have up, right. Now we are learning up a lot of data structures, different types of data structures. Now what's the need? Generally, what is the need for the hash data structure? Why is it actually required? Right, so like every day we have the lots of data over the internet, right, and we know that it is quite very much increasing and increasing only, right. Now there's like if you want to store our data, there's always a struggle about storing up this respective data in an efficient manner. What I'll do, I'll keep on writing as well. So okay, so the data on the internet is increasing, and it is always a struggle, to store this data efficiently. right? The data on the internet, it is increasing, and it is always a struggle to store this respective data efficiently, right? Now, in day-to-day programming, right? In day-to-day programming, this amount of data might not be that big, but still it needs to be stored, comma, accessed and processed, right? And processed easily and efficiently. So a very common data structure that is used for such a purpose is array data structure, right? So now, like, generally we have this hashing over here, this respective data type, that is the hashing data type. Now what is the need for this particular data type or data structure over here? So the need is that the data onto the internet, that is in quite very much increasing nowadays, right? And every time there's a struggle, there's a thing that how will this data be stored, right? So storing of that respective data, this is respectively always a sort of a thing which needs to be looked after, right? So in day-to-day programming, this amount of data, it might not be that big, right? In day-to-day programming, if we talk about the day-to-day programming, so this amount of data, it might not be that big, but still this data as well, it needs to be stored, it needs to be accessed, and even it needs to be processed very easily and efficiently, right? So in that particular one, so a very common data structure that is used for such a purpose, that is your array data structure. Now that up till now we know that, okay, what is the need and which data structure is a common, which one can be used for such purposes. Now the question arises that if array was already there, right? Now the question is, if array was already there, what was the need for a new data structure, right? So as I was discussing about that, okay, for this common data structure, for solving that purpose or just solving of that particular problem, we can have this hashing, right? Now the question which comes up over here is that if array was already there, it was already there at that time, so now what was the need for a new data structure, right? What was the need for that particular thing, right? So the answer to this is in the word efficiency. We know that arrays are not that very efficient, right? That is quite very clear. So now if we talk about in terms of efficiency, right? So if I see, though storing in array generally takes the complexity of big O of 1. Right, storing in array takes the time complexity of big O of 1, right? Okay, searching in it at least, it takes us like big O of log n. Searching into it takes the time complexity of the big O of log n, right? So one second. So this time appears to be small, but for a large data set, this time appears to be small, but for a large data set, it can cause a lot of problem. And this is what makes this array data, okay, one second, which makes this array data structure inefficient, right? So now this is the thing is that when we have this hashing, right, when we have this array was, if already was there, then what was there a need for a new data structure, right? Why did we require up a new data structure? What was the need for the same? So now the answer for this particular question can be, now it can be that there is a term which is known as efficiency, right? Now if you want to store something in array, it takes big O of one time, right? Searching in any array, it can take at least big O of log n as a time complexity, right? But now this time which we have in this might seem small, right? This might seem small over here, but basically for a large data set, if we are having up a large data set, so in that case what it can do, it can cause up a lot of problems for us, right? If the data set is quite large, it can cause up a lot of problem for us based upon the time as well, and that is what makes this array data structure inefficient, right? So okay, I'll starting writing. So now we are looking for our data structure, right? So now we are looking for a data structure that can store the data, and search in it in constant time. Okay, that is one time, right? So now we're looking for data structure that can store the data and search in it in constant time, that is in big O of one time. So this is how hashing data structure came into play. This is how hashing data structure came into play. So with the introduction of the hash table, or I would say hash data structure, right? With the introduction to this particular data structure, it is now possible to easily store data in constant time and retrieve them in constant as well, right? So when we found out that okay, arrays are very much inefficient for us as a data structure because of it might take a longer time if there is if there are some large data sets, right? So now we are looking for a data structure that can store the data and search in it in the constant time, that is maybe in big O of one time, right? So this is how the hashing data structure came into the play. We wanted a type of a data structure that can store all the data very efficiently, search it into a constant time, right? So even it should have the complexity of big O of one time, right? So this is how this hashing data structure it came up into the play, right? So with the introduction of the hash table data structure, now it is now possible to easily store the data in constant time, retrieve that data as well into a constant time, right? That is what we are having up over here first of all, right? Now getting down. Now if we talk about that, okay, what are the components of the hashing? Basically, what do we have up into the hashing? So I can write components of hashing, right? Components of hashing. So generally in majority or general there are in total 3 components of hashing. Okay, there are in total 3 components of hashing which we have up over here, right? So the very first component is a key. Okay, then we have up a hash function, and then we have up a hash table. So this is one second, yeah. So this is how all these components of hashing we are having it. So we can start with those components. So there are 3 components of hashing. So the number 1 is a key. Okay, now what is that? So a key can be anything. So a key can be anything. It can be a string. It can be anything. A string. 1 second. Or integer, which is fed as input in the hash function, right? So what can be a key? A key can be a string, or it can be an integer also, which can be put down as an input. Okay, which can be put down as an input into the hash function, right? So hash function, the technique that determines an index or location for storage of an item in a data, right? So a key can be any type of a data structure. It can either be a string, or it can either be a INB or integer, right? So which is completely gonna put up the input in the hash function, which will help us to give the input in the hash function, the technique that determines up the index or location for storage of an item in a data structure. That is what is a key. So in simple, you can even say that what is a key? A key is a simpler data which will be put down into the hash function, right? Second, we are having a hash function. Now what is a hash function? So the hash function receives the input. So the hash function receives the input key, and the hash function receives the input key and returns and returns the index of an element in an array called a hash table. Right. So what is a hash function? A hash function receives the input key and returns the index of an element in an array, which is called as a hash table. Now this is known as the hash index. Right. So whatever the input keys are being given, right, those are received by a hash function. Right. And it is returning up the index of any element of the array, and that respective thing, that is completely known as your hash table. So this is known as the hash index. Okay, so I hope I am pretty much clear with the same. And moving to the point number 3, we are having a third term, that is my hash table. Okay, let me make a small. Now we can discuss even that what is a hash table in real, or what is it actually. Right. So hash table is a data structure that maps keys to values using a special function called a hash function. First of all, understand this thing. Hash table is a data structure that maps the keys to values using a special function which is called a hash function. Right. Now the hash stores the data in an associative manner in an array. One second. In an array where each data value has its own unique index. So hash table, that is a data structure that maps the keys to the values using a special function called a hash table. Right, called a hash function. Now the hash stores the data in an associative manner in an array where every data value which is having, it has its own unique index. Right, so with that unique index only, this hash stores the data in an associative manner. That is what we have up over here into the hash table. So these are the 3 very important components about your hashing: key, hash functions, and the hash table. Right. Now how does this thing works actually? We have learned that what is it used for, types even we have learned the properties as well. Now it's the time to understand that how does hashing works, right? So how does hashing works? Okay, great, let's understand about that. So now what I'll do, I'll help you to explain up this thing with a quick example only. Okay, so suppose we have a set of strings. Okay, and let's say those strings are AB, comma, okay, one second, comma, CD, comma, EF, G. Okay, let's say these are the set of strings which we have, let's say, right? And we would like to store it in a table, right? And we would like to store it into a table. So let's say I have a set of strings A, B, C, D, E, F, G, and we would like to store it into a table, right? So our main objective our main objective here is to, so our main objective here is to search and update the, okay, is here to search and update the values stored in a table quickly in big O of 1 time, and we are not concerned about ORDE about the, and we're not concerned about the ordering of strings in the table, and we are not concerned about the ordering of the strings in the table. So the given set of strings can act as a key, and the string itself will act as the value of the string. But now the question comes, how to store the value corresponding to key, right? Now how we will put in, or we will store the value corresponding to the key. So our main objective here is that we can just search or update up the values which are stored up into a table quickly in generally big O of 1 time, right? And even we are not concerned about the ordering of the strings in the table, right? So whatever there is a given set of a string, they can act as a key, and the string itself will act as the value of the string. But now the question comes, how to store the value corresponding to key? How do you store up that particular value which is corresponding to the key, right? So here goes some steps which we need to follow. So my step 1 is that we know that hash functions are used to calculate the hash value which acts as the index of the data structure where the value will be stored, right? So that is the very one step that we know. We know that the hash functions which are completely used out to calculate up the hash value. Okay, let me write in the correct spelling. Hash value which acts as the index of the data structure where that respective value will be stored, right? Okay, now further if I move and if I talk about my step number 2. So in this step number 2, what you could do, you can sign up the things in the alphabetical order. Let's say I have the value for the A as 1 second. I have A, let's say 1, and then let's say I have B, and that is equal to, let's say, 2, right? So A is my 1, B is my 2. So that is the one thing first of all which we have up, right? So I just assigned out the values. Then will be my step number 3 which has to be followed. So now for the following of this step number 3, into that what is to be done? Now therefore the numerical value by summation of all characters of the string. So what you could do, you can just simply do a summation of all the characters of the string in the step number 3. Then will be my step number 4. Now what has to be done? Now you have to assume that we have a table of let's say of the size as 7, of size 7, to store these strings, right? To store these string. Let's say that's what I have. Let's assume that we have a table of size 7, which is for storing the strings over there, right? So the hash function that is used here, is the sum of the hash function that is used here is the sum of characters in key mod table size, right? So in that case, what can be done? We can compute the location of the string in the array by taking the sum into the bracket string, mod 7, right? That is what could be done. So now you just have to assume that you have a table of size 7 for storing up the strings, right? So the hash function that is used up there is the sum of the characters in key mod table size, right? So what you could do, you can compute up the location of the string in the array by taking the sum of that string and mod by 7, right? So then you can store up the value for the AB or CD or EFG, whatever you will be having. So whatever all the things which we have written up over here, so this particular technique, it helps us to calculate the locations of a respective given string by or with the help of a simple hash function. First of all, it helps us to calculate up the location of a given string using up a very simple hash function, and then rapidly finding the value that is stored in that respective location. So now therefore the idea of hashing, it seems like that it is one of the best ways, right, for storing up the keys or for storing up the key value pairs of the data into a table. So yes, actually hashing, that is one of the best ways which you can use in for storing up at least a key and a value pair over there which we have up into our dictionaries, right? Great. So I hope that particular thing is quite very clear. So now if I talk a little about that, what is a hash function, right? So this respectively just helps us to create up a map between a key and a value. So with the help of this hash function, you can be able to create up a map between a key and a value. So that is completely done in with the use of the mathematical formulas which are known as the hash functions. With the help of mathematical formulas which are your hash functions, this particular thing, it can be done, and that is known as a hash functions, right? So now the result of those hash functions, it is referred to as a hash value or hash, right? And what is a hash value? It is even a representation of the original string of characters, but usually it is going to be small than the original only. So it can be a small character than the original one, right? Let's say I have an array as a, let's say, map, right, where we have keys in the index, and the value which we are having, that's the value at an index. Okay, so let's say my array is A, and if I have to let's say and my index is I, right? So if we have index I which will actually be treated as the key only, then in that case we can very simply or very easily find the value of all the values at A of I, right? So you can just simply find that, okay, what's the value at a of 0, what's the value of a at a of 1, what's the value of at a of 2, and you will very simply get in all the desired results, right? That is what we have up over here. Okay, now if I talk about the types of hash functions, right? Types of hash functions. So number one is my division method. That's the very first type of the hash function which we have, the division method. Okay, next we are having the mid square method. That's the number 2 type. Third one is my folding method. Okay, now, okay, one second. We need to correct the spelling. The third one is my folding method. Right, point number 4. Number 4 is my multiplication. Okay, one second. Multiplication, multiplication method. So these are the 4 types of the different types of the hashing which we have up over here. The division method, right? The mid square method, the folding method, and the multiplication methods. Right, now this is the one thing. Secondly, now if I talk about that, what are the properties of a good hash function? Right, that what are the properties of a good hash function? So now in that case, it's all over, like many things are there which would give a factor as a good hash function. So some are, one is like the efficient, it is very efficiently computable. A good hash function, it might have in these particular properties. Basically, it should be efficiently computable, it should uniformly distribute up the keys, right? It should minimize the collisions, it should have a new load factor. So these are all the things which are there, which are to be taken care of. So a good hash function, it should just have all of these following properties of efficiently computable, should uniformly distribute the keys, should minimize the collisions, and should have a low load factor. These are some of the I'll say the properties of a good hash table. So I'll give you a very quick review whatever we have discussed up till now over here. So hashing, it refers into the process of generating a fixed size output from an input or for input of variable size with the help of the mathematical formulas which are your hash functions. Now this technique determines an index or locations for the storage of the items in a data structure. Now what is the need for this hashing? Now the data onto the internet which we have, that is quite increasing day by day, and it is always a struggle to store that data efficiently, right? Now in day-to-day programming, this amount of data might not be that big, but still it needs to be stored very carefully, it needs to be accessed and processed very easily and efficiently, right? So a very common data structure that is used for such a purpose is array data structure, right? Now the question arises, it comes that if array was already there, what was the need of a new array data structure, or what was the need of a new data structure? So the answer to this question is in the word efficiency. Though storing in array takes big O of one time, right? Searching in it at least big O of log n. So this time appears to be small, but for a large data set, it can cause a lot of problem, and this is what makes this array data structure inefficient. So now we want a type of a data structure that can store the data and search in it as well in the constant time, that is in big O of one time. So this is how the hashing data structure came into play. So with the introduction to hash data structures, it is now possible to easily store all the data in constant time and retrieve them in the constant as well. That is one thing about the hash and the need for that. Now what are the components of hashing? So total 3 key hash function hash table, right? So key, it can be anything, any string or integer which is actually treated as an input into the hash function. So that particular technique determines an index or a location for storage of any item in a data structure. That is what is a key. Talking about the hash function, so hash function, it receives the input key and returns the index of an element in an array which is called as the hash table. So this is known as the hash index, right? Talking about the hash table, it is a data structure that maps the keys to the values with the help of a special function called a hash function. And even the hash stores the data in an associative manner, in an array where each data value has its own unique index. Now how does hashing works out actually? So let's say we have a set of strings A, B, C, D, E, F, G, and we would like to store it into a table. So our main objective here is that we need to search or update the values which are stored in a table quickly in big O of one time. And we are not concerned about the ordering of the strings in that table. Right, so the given set of string that we have, that can act as a key, and the string itself, it will act as a value of that string, but how to store the value corresponding to the key, right? So now here we are having a few steps that need to be followed. The very one is that we know that hash functions are used to calculate the hash value, right, which acts as the index of the data structure while the value will be sorted. Second is that we just assign up those values. Third is now therefore the numerical value by summation of all characters of the string, right? 4 is that now we can assume that we have a table of size 7 to store the strings. So the hash function that is used here is the sum of the characters in the key mod table size, right? So we can compute up the location of the string in the array by taking the sum mod 7, right? And now if we talk about what are the types of hash functions, so here we are having different types of hash functions, like in your division method, your mid square method, your folding method, your multiplication method, right? So I hope I am very much clear to everyone about this hashing, that what is it, what are the things which we are having, and everything about the same, right? So if you have enjoyed this video, do like this video, do share it with your friends, and do not forget to subscribe out my channel. We'll see you there in the next video.